My name is Jeffrey, and the topic we are going to be discussing today is rational expressions. Here's learning objectives, and in this section you'll learn to simplify rational expressions, and also multiplying rational expressions, and dividing rational expressions, and also adding and subtracting rational expressions. So the first one is simplifying rational expressions. So the quotient of two polynomial expressions is called a rational expression. And we can apply the properties of fractions and rational expressions, such as simplifying the expressions by canceling the common factors from the numerator and the denominator. So to do this, we first need to factor both the numerator and the denominator. So let's look at this example. X squared plus 8x plus 18, or plus 16, over x squared plus 11x plus 28. So if we do factoring on both the numerator and the denominator, we'll end up getting x plus 4 whole thing squared over x plus 4 times x plus 7. But here we got like x plus 4 at the top and also x plus 4 at the bottom, so we can cancel that out. And what we'll get is x plus 4 over x plus 7. Okay, the next one is multiply rational expressions. So multiplication of rational expressions works the same as multiplication of any other fractions. So we first multiply the numerators to find the numerator of product, and then we do the multiplication for the denominators to find the denominator of the product. So before multiplying, it is helpful to always factor the numerators and the denominators first, just as we did when simplifying rational expressions. So yeah. The next one is dividing rational expressions. So division of rational expressions also works the same way as division of other fractions. So to divide the rational expressions by another rational expression, multiply the first expression by the reciprocal of the second. Using this approach, we could rewrite, let's say 1 over x divided by x squared over 2 over 3. So as the product of 1 over x times 3 over x squared. So once the division expressions has been rewritten as a multiplication expressions, we can then multiply as we did before, like this. So it is originally 1 over x times, or 1 over x divided by x squared over 3. So we have to do the reciprocal of this one, which gives us 3 over x squared. And then we can simply do the multiplication for both the numerator and also the denominator. Yeah, so we'll end up getting 3 over x cubed. The last one is adding and subtracting rational expressions. So adding and subtracting rational expressions also works just like adding and subtracting numerical fractions. So to add fractions, we need to find a common denominator. So let's look at this example of fraction addition. So for instance, we got 5 over 24 plus 1 over 40. So see, they got different denominators. So what we have to do first is to find their common denominator, and we want to find the least one, so it won't the number won't get too big. So first, we'll figure out that 24 times 5 is equal to 120, and so is 40 times 3. So if we do a multiplication for the denominator, we also have to do it for the numerator. So that way it cancels out, which means that we're just multiplying 1 to these fractions, which won't change their original number. So if we multiply 5 for the denominator of 5 over 24, we will also have to multiply by 5 for the top one. So we'll end up getting 25 over 120. Same with 1 over 40, which if we multiply by 3 and 3 at the bottom, we'll get 3 over 120. And notice that these two numbers is still the same as this one. If you do factoring for this one, you'll end up getting this one. But yeah, and once we get the same denominators for both numbers, we can simply just add them up, which will give us just 25 plus 3 all over 120. So we get 28 over 120. Then we can simplify that into 7 over 30. So we have to rewrite the fractions so that they share a common denominator before we are able to add. So we must do the same thing when adding or subtracting rational expressions. So the easiest common denominator to use will be the least common denominator, or the LCD. The LCD is the smallest multiple that the denominators have in common. So to find the LCD of two rational expressions, we factor the expressions and multiply all of the distinct factors. For instance, if the factor denominators were x plus 3 times x plus 4 and x plus 4 times x plus 5, then the least common denominators would be the whole thing, which is x plus 3 times x plus 4 times x plus 5. Because if we want to get this out of this one, we just have to multiply by x plus 5. And same thing with this one. If we want to get this thing out of this thing, we'll just have to multiply by x plus 3. So the least common denominator for these two would be x plus 3 times x plus 4 times x plus 5 times x plus 5. Yeah. So once we find the LCD, we need to multiply each expression by the form of 1. That will change the denominator into LCD. We would need to multiply the expression with the denominator of x plus 3 times x plus 4 by x plus 5 over x plus 5, because this thing over here is just 1. So it will not change the original quantity of this one. So and the expression with the denominator of x plus 4 times x plus 5 will be by multiplying x plus 3 over x plus 3. Same thing here, it is just 1. So will not change what it is. So let's do some practice questions. So the first one is simplifying rational expressions. So the first question asks ask you to simplify x squared minus 9 over x squared plus 4x plus 3. And the second one asks you to simplify x minus 6 over x squared minus 36. Yeah, so I'll give you guys, let's say 30 maybe 40 seconds to work on. So just simplifying these two, starting from now. Okay, so the answer you should be getting for the first one is x minus 3 over x plus 1, because if you factor the x squared minus 9 out, you'll get x plus 3 times x minus 3. And then for the x squared plus 4x plus 3, if you do factoring for this one, you will get x plus 3 times x plus 1. And here you got both x plus 3 and x plus 3 at the top and the bottom, so you can just cancel that out, which leaves you with just x minus 3 over x plus 1. Yeah. And for the second one, if you do factoring for the bottom one only, because you don't have to factor the top one is in its simplest form. So if you do factoring for the bottom one, you'll end up getting x plus 3, x plus 6 times x minus 6, and you can cancel out the x minus 6 at the top and the x minus 6 at the bottom, which will give you just this should be 1 over x plus 6. My bad. Yeah, the answer is 1 over x plus 6, not just x plus 6. Okay. Alright, so the next question, multiplying the rational expressions and show the product in the simplest form. So you have to multiply this x squared plus 4x minus 5 over 3x plus 18 times 2x minus 1 over x plus 5. So it is a little bit harder, so I'll give you like a minute to work on this. Okay, and that's start from now. Okay, so here's the answer. You have to first do the factoring for the numerator and the denominator. So if you do factoring for this one, you'll get x plus 5 times x minus 1. And here you can also factor out the 3. So it will gives you just 3 times x plus 6. And for these two, you don't have to do the factoring because it's in the simplest form, so you don't have to do that. And then you can start like multiplying. Just put them in one big line, draw one big line, and these should be put at the numerator because it's still numerator. Notice that it's just multiplication, not dividing, so you don't have to like do the reciprocal of these. Yeah, and then once it's in like one big rational expression, you can start doing the canceling. So here you got x plus 5 at the top and x plus 5 at the bottom, so you can just cancel that out. And for the rest of them, you notice that they cannot be canceled out, so you'll just leave it like that. So once you cancel out the x plus 5, it leaves you with just x minus 1 times 2x minus 1 over 3 times the whole thing x plus 6, and that will be your answer. Yeah. Okay, so for the next question, dividing the rational expressions and the expression and express the quotient in its simplest form. So this is basically the same as the last one. But instead of multiplication, it tells you to do division. So yeah, I'll give you guys again 1 minute to work on this, starting from now. Okay, so here's the answer. And so similar with the last step, instead you have to do first do the reciprocal of this one. So just flip it up, so you'll get these still the same. So 2x squared plus x minus 6 over x squared minus 1 times the reciprocal of this, which is 2x x squared plus 2x plus 1 over x squared minus 4. So once you get this, you can start factoring out the numerator and the denominator. So you'll get for this one, you'll get 2x minus 3 times x plus 2. And here you get x plus 1 squared for this one, x plus 1 squared. And then for the bottom one, you get 2 x plus 2 times x minus 2 for this one. But it's at the bottom since it's reciprocal. And this one should be at the top, like this. Yeah, so once you finish factoring, you just put them together, so you'll get this one, and you can start canceling out the common factors. So for this one, here's x plus 1, and here's also x plus 1. You can cancel them out. And for this one, there's x plus 2 at the top, and also x plus 2 at the bottom, so you can also do the canceling. And then yeah, I think that's it. So yeah, after you finish canceling, you should get this one, and this is the answer. Okay, so for the last question, it's pretty simple. So add the rational expressions of 5 over x plus 6 over y. Notice that for this one, they don't got the same denominator, so you have to first do the multiplying to get your v's common denominator. So yeah, go ahead. And I'll give you guys just 40 seconds to work on this. Start from now. So for the answer, it should be pretty straightforward. So you have to first find the least common denominator for these two. So obviously for these two, they don't got the same thing at the bottom. So you have to multiply y over y for this one, and then x over x for this one. So once you multiply that, you'll get 5y over xy plus 6x over xy. Yeah, and you'll get this. So now just combining the two, since you got the same denominator, you can just plus the just adds up the two thing at the top. So it's just 5y plus 6x. Yeah, over x times y. So the answer is 5y plus 6x all over xy, and that'll be your answer. Yeah, and that's pretty much for today. And thank you for listening. See you.